Hey everyone, welcome to the Motion Master. Today we're starting with one of physics' most important topics, which is the Newton's three laws of motion. These laws help explain how and why everything moves the way it does. Okay, Newton's first law is the law of inertia, and it states that an object will remain at rest or keep moving at a constant speed in a straight line unless acted upon by an external force. And basically, inertia is an object's resistance to a change in motion. Okay, so let's say I have this ball and it is resting on a flat surface. In real life, if I roll it, if I apply force, it will keep moving forward, but eventually things like friction between the ball and the floor or the air resistance will slow it down. However, in a vacuum, like in a space where there's no friction, no air resistance, it would keep moving on forever. In real life, when you're in a car that suddenly stops, your body keeps moving forward. That is inertia in action, and that is the reason that why we need to use seat belts. Okay, so the second law of motion is the law of acceleration. Newton's second law explains how force, mass, and acceleration are related through the formula force is equal to mass times acceleration. And okay, it says that the acceleration of an object depends on the net force and, well, the net force applied to it and the mass of the object. We use force in newtons, mass in kilograms, and acceleration is measured in meters per second squared. Okay, I have this box here. No, I have this. Sorry, I have this box here, which is resting on a flat surface again. And let's say I apply a force of 10 newtons in this direction to the box, and let's say that the box has a mass of 2 kilograms. So in order to find the acceleration, I would need to divide 10 newtons by 2 kilograms, and that would give me 5 meters per second squared. So that is the acceleration of this box. This law explains why pushing an empty shopping cart is easier than pushing a full one, because more mass needs more force to accelerate. Okay. Now, the third law of motion is the law of action and reaction, and it states that for every action there is an equal and opposite reaction. An example I could give you is, let's say I have this space rocket, and obviously, okay, when an object pushes another, the second object pushes back with the same force but in the opposite direction. The forces are equal in size, opposite direction, so when a rocket fires up, it leaves a trail of the fuel it uses, which goes down, and these forces are equal and opposite in direction. The rocket is pushed up and the gas is pushed down, and that is what allows the rocket to move. Or another example is when you jump off a boat. I don't know if you've noticed that when you move forward, the boat moves backward. So both forces are equal and opposite. I think I've said that phrase a lot of times. Okay, and Newton's laws are everywhere. There are in driving, in sports, or even in space travel. The first law teaches us why seatbelts are important. The second law is why heavier cars take longer to stop. And the third law is how rockets and jet engines work. So now I want to do a quick problem example. If a 3 kilogram object accelerates at a rate of 4 meters per second squared, what is the net force? So the formula would be force is equal to mass times acceleration, and the mass is 3 and the acceleration is 4, so the force would be equal to 12 newtons. And basically that is Newton's three laws of motion. They are the foundation of physics.